Differentiable functions have many nice properties. We'll talk about one of these in this video. Consider this graph of a differentiable function. This line's slope is the average rate of change of the function on the interval from a to b. If we shift this line down without changing its slope, we see that it becomes a tangent line at x equals c. This means that f prime of c equals f of b minus f of a over b minus a. In words, the average rate of change of f of x on the closed interval from a to b is realized as an instantaneous rate of change of f of x on the open interval from a to b. We make this formal in the mean value theorem for derivatives. If f of x is continuous on the closed interval from a to b and differentiable on the open interval from a to b, then there's a number c in the open interval from a to b such that f prime of c equals f of b minus f of a over b minus a. Note that we don't assume that f of x is differentiable at the endpoints of the interval, so the function f of x equals the square root of x, for example, satisfies the conditions of the theorem on the interval from 0 to b for every b greater than 0. Let's now look at a function that doesn't satisfy the conditions. Let f of x equal the absolute value of x, and let ab equal the interval from -1 to 1. The average rate of change of f of x on this interval is 0, but at no point is the instantaneous rate of change 0. To see this graphically, here's the graph of the absolute value of x, and here's the line whose slope is the average rate of change of the function on -1 to 1. If we shift the line up or down, it never becomes a tangent line. The problem is that right here, the function has a corner. The mean value theorem has many consequences, one of which is this theorem. If f of x is differentiable on the closed interval from alpha to beta, and f prime of x is 0 for all x in that interval, then f of x is constant on that interval. I leave the proof as an exercise for you. 2 questions. First, does this theorem hold if we replace the closed interval from alpha to beta with the open interval from alpha to beta? Second, if f of x is differentiable and f prime of x equals 0 for all x in its domain, then is f of x constant? The second question is asking whether the theorem still holds if we no longer assume that we're working with an interval. I'll leave you with one more question. Does the conclusion of the mean value theorem still hold if we allow the function to have vertical tangent lines in AB?